9.1, or actually all of Unit 9 is working distance, rate, and time. 9.1, we're just going to review the distance, rate, time formula and do some word problems having to do with distance, rate, and time. So, do you guys remember distance, rate, time formula?
No. From science.
Okay, distance, rate, and time. Distance, which is usually miles or feet, equals rate, which we typically get miles per hour, times time. What's another way that we can write that? D equals RT, right? Okay, so D equals RT is the abbreviated way to write it. Okay, for most of these problems, you are going to be given either distance and rate, two of them, and plug it in and having to solve for the other. Okay, not too bad. The hardest part about these problems is deciphering what is what in the problem. So let's look at example 1. How far will it take Yannicka to go 420 miles driving at 35 miles per hour? 420 miles. Is that a distance, rate, or time? That is a distance. Oops. Driving at 35 miles per hour, distance, rate, or time? That's the rate. So what we're going to do is we're going to plug it in. 420 for distance. So we get 420 equals 35 miles per hour. That's our rate. So 35 times, what do you want to do the T for time?
Divide.
Okay, so how do I solve for T? Divide by 35. So T equals 12 what? Well, let's look at our units. We have 420 miles, 35 miles per hour. So what do you think our time is going to be in?
Hours.
In hours. Yeah. And that's it. This should be reviewed from pre-algebra.
I'm just going to say that.
Okay, so 12 hours. Okay, questions so far? Well, because our units is 35 miles per hour, so our time is going to be in hours. Our units all have to be the same. Okay, so let's look at example 2, guys. How far does Belinda go, or how far has Belinda gone if she drives 60 miles per hour for 30 minutes? Do my units match up?
No.
No. My rate is miles per hour. My time is in minutes.
It would be 30 miles.
Okay? So if my rate is in miles per hour and my time is in minutes, how can I rewrite my time so that it's in hours? 30 minutes equals how many hours? Half an hour. So 0.5 hours. 0.5 hours. Right? Okay. Our rate is miles per hour, but our time is in minutes. We need our time to be in hours also. 30 minutes is how much of it? How many hours? Half an hour. 0.5. Okay, so will we be solving for distance, rate, or time here? Distance. So we're going to get D equals 60 times 0.5. So what does that give me? 30 what? Well, we're looking at distance. So it's going to be a measurement of distance, and our rate is miles per hour, so our distance is going to be miles. So you have to think about the variable, and then you have to think about what your units are. Okay? Example 3. Okay, this one is, we're actually working with a couple distances here. How many miles has Travis gone if he drives at 60 miles per hour for 2 hours and then hits rush hour traffic and drives 20 miles per hour for 1 hour? I have two distance, rate, and time formulas here. What is my first one? 60. I'm going to use 60 miles per hour as my rate and 2 hours as my time. So we're going to call this distance 1 equals 60 times 2. So distance 1 equal what? 120 what? What are the units? Miles. Okay, that's distance 1. Distance 2, because we now have rush hour traffic also. What's the rate for distance 2? 20 miles per hour, and what's the time? 1 hour. So distance 2 is 20 times 1, which gives me what? 20. So, for the first 2 hours, he traveled 120 miles. That's what it's saying. For the next 1 hour, he only traveled 20 miles. So how far did he travel total? 140. So distance total equals 120 plus 20, which equals 140 what? Miles. Okay, so sometimes there will be problems where it's more than one part. Okay, so make sure that you are reading each problem carefully and that you are answering the question that's being asked of you. Example 4. Katie rides her bike from Clovis to Shaver Lake. On the flatland, she travels at 20 miles per hour for 1 hour. In the mountains, it takes her 3 hours to go 36 miles. Find her average rate for the trip. Okay, so, and I gave you the average is equal to total miles over total hours. So we need to find out the total number of miles first. For the first part, do we know how many miles she traveled yet? No, but we know her rate and her time, right? So let's do that. So rate and time. So this is distance 1 equals 20 times, what was her time? 1 hour. So how far did she travel?
40 miles.
20 miles. In the first part, on the flat part. Okay, now let's read the next part. In the mountains, it took her 3 hours, that's a time, right? To go 36 miles. Is that a rate or a distance? So do we know how her distance in the mountains? Yeah, it was 36, right? So how do I find her total distance? Add what? Okay, her distance total. We know the flat part was 20 miles. Plus, what was the how much did she go in the mountains?
36.
36. So we didn't have to do distance, rate, and time for that one, right? So what was her total distance? 56 miles. Okay. Next part. In order to find her average rate, we need her total miles, which we just found, 56. And we need her total hours. How could I figure out her total hours? Add 3 and 1. So her time total is equal to 1 hour, that was the flat part, plus 3 hours. So how many hours did she ride? 4 hours. Okay, so how do I find her average? Divide. So average equals total miles, which was 56 miles, over total hours, which was 4 hours. That reduces by 4. So we get an average of 14 what? Miles per hour. Good. Javier. Oh, well, first of all, we can also use distance, rate, and time formula for things that are not necessarily distance, rate, and time. So let's read example 5. Javier can travel 154 miles. Is that a distance, rate, or time? That's a distance. On half a tank of gas. This is just half of his tank. His car gets 22 miles per gallon. Is that a distance, a rate, or a time? It's a rate. Miles per gallon. It's still a rate. How many gallons does his car hold? So what's going to be taking place of time here is how many gallons of gas his car holds. So that's going to be our T. The gallons of gas is going to be our T here. Okay? Now what's something that we have to recognize about this certain set of data? How much of the tank did he use? Just half of it. So when I plug this into distance, rate, and time, distance is 154. That stays the same. Rate is 22. Times what? 0.5 T times 0.5 T. Because he only used half of his tank, but we don't know how much that is yet. Okay, so times 0.5 T. Okay, so that's 154 equals, what's 22 times 0.5? What's half of 22? 11. Move your decimal. So 11T. So then what do I do to solve for T? Divide by 11. So T equals? $14 what? Gallons. What was the problem asking us? How many gallons does his car hold? 14. So you can also use distance, rate, and time in other ways. You just have to be able to recognize what's the distance, what's the rate, what's the time. Okay?